Hello, I'm going to do a little walkthrough of a demo that I created using the C# version of the Serverless Framework to deploy a skeleton REST API to AWS Lambda. So there's a bunch of examples out there for the Serverless Framework, and a lot of them are in Node and Java. There's one in .NET. I thought I would go ahead and just, as I was trying to figure out how it worked and how to properly compile it and deploy it, I thought I would just create a skeleton REST API that has a standard get and put and post and delete. And I'll put it up on GitHub. And if anyone's interested in, using the serverless framework in C#, they could, download the version that I have up there on GitHub and change it to your heart's content. It's basically just a standalone, as you'll see. So what is the serverless framework? I don't claim to be an expert in it. I was just kind of poking around with it, and I know they're using it at the workplace too, and I've taken some courses in it with Node.js, but I wanted to go ahead and figure out what the C# experience is. So the serverless framework is basically, it's an open source web framework, and again, it's written in Node.js, and it allows you to create your applications and deploy them over to Azure, AWS, Google Cloud, even I think it's like OpenWhisk or something like that. But the idea is it's similar to it's like an abstract layer on top of your specific cloud provider. So I almost akin it to Xamarin, where you can do some cross-platform development. You can write your code, and then you can relatively easily deploy to your iOS device or your Android device. Serverless Framework allows you to write code that'll deploy it as a Lambda function over in AWS or as your function on Azure. And I'm honestly not really sure what the equivalent in GCP is. But there's a lot of good documentation out there on the serverless framework. And so I was going to just do a demo on how to do it in C#. So I was going to start with the real basic hello world. So first of all, you got to make sure that you install your serverless with an npm install. And I'm going to go ahead and cd to directory that I have. And what I'm going to go ahead and do is run the C# command to create a hello world template. And what I'm going to do there is I am going to run a command. Once you install the serverless framework, you can use SLS. So I'm going to say create template AWS C#. And there's a whole bunch of these given things. If you were to do a SLS create and help on it, you'll see one for Java and some of the others, but I'll just focus on C# here. And I'm just going to go ahead and call this hello. We'll call it the hello service, I guess. And what it's going to do, now this also assumes that you have the AWS CLI up in place when you've got that going. So it successfully created a boilerplate, and it created in the hello service directory. So if I cd to that, if I can type, that is, okay, you can see that it went ahead and created some files here. So I'm going to open up code, and we're just going to deploy this without really doing anything here. And then I'll show you a little bit about the code, and then I'll show you the REST API that I've got up there. So give this a second here. We'll do the interactive terminal. Let's see. Okay. So we have a PowerShell going on here. Out of the box, they give you this build command for PowerShell. So let's go ahead and just run it. Sure would help if I Did a dot slash there. Never fails whenever you're giving demos and stuff like that. You run into some issues here and there, but I guess that's what makes things really interesting. So we went ahead and built this. So this build command just does a .NET restore and then a .NET Lambda package. So it'll go ahead and create a package zip file, and we're not done yet. So now I'm going to go ahead and deploy this up to my AWS cloud. So let's do a SLS deploy. Let me do a command prompt. And as you can see, it's packaging the service, creating the stack. Now this also assumes that you have AWS configure properly set up to, with your key and your account. So without that, this won't be able to go ahead and upload this information. So give it a second, and I will pause this video and wait for that to finish. Okay, what this actually is doing, I thought I would, there we go, it just finished. I'll go ahead and show you my account. And what this actually did was it created a cloud formation stack. Serverless Framework creates a stack, and so it actually generates a template, uploads it, creates a stack, runs it. So that's what we've got going on here. There's really not much to this given template here, but you can see this was generated by the Serverless Framework. So if we take a look right here, what we've got here is the name of the service. That was when I went ahead and created the SLS create. Here's our stack. And basically the function itself is hello service, dev hello. And if we wanted to go ahead and try to run this, well, let me just show you this here. So let's go to our Lambda. And there's our new new Lambda function right there. So it's the hello service, dev hello. And what we can do is go ahead and run it. So we'll just create a new test event. It doesn't really matter what we call this test event. And we'll go ahead and create this, and we'll test it. And as you can see, it successfully executed our function. So what we've got here out of the box, when you generate that C# template, basically it generates this C# code for you, this handler. And it's just nothing more than a kind of like a hello world version of it. So it just basically got a request object and a response object, and it goes ahead and executes that. So what I was going to do, or what I ended up doing, was creating a much more robust example, more than a hello world, one that developers out there, if they are interested, can choose to download and use. So let me go ahead and bring that one up. But before I do that, I wanted to actually show you how easy it was. Since we went ahead and deployed the service itself, let's go ahead and remove it. So you could say SLS remove. And what that's going to do is it's going to remove, as you can see, it's just like doing a delete stack inside of your CloudFormation template. So let's go back to CloudFormation. As you can see, our stack is now gone. So the nice thing about the serverless framework and the commands is basically it'll provision your CloudFormation template so you can deploy your package, and if you no longer need it or need to make changes to it, you can go ahead and delete it. And it creates this .serverless directory, so you can actually take a look at the stack itself that it creates. If you want to have poke in to see some interesting stuff. So having said that, let me go ahead and show you the REST API. Okay, so I thought I'd spare you guys having to see me type in all of this stuff. So this is up on GitHub, and I'll go ahead and provide a link to it on the video. But probably it might be easy just for me to run this first and then kind of go through the code just a little bit. So let me just go ahead and build this. I'm going to run this /build command so that you can see that this is building. This one's a little bit more of an aggressive project. So it has a mock repository. It has a model object that you can use, and it's got our functions. So we've got our post right there, which is our create member function. We've got our delete. We've got our get. We've got our basically our list where it's going to return all the members. The one up here returns a single one, and then this is going to do a put. Your standard REST operations. So the build itself went ahead and created this package. So we're going to go ahead and deploy this. And I'm going to go ahead and say SLS deploy. And you got to be in the same directory as your root project, because the SLS deploy is going to actually take a look at your the generated cloud formation templates. So let's go ahead and run SLS deploy. And while that's running, what I wanted to mention is because this is a REST API that we're creating, it's going to go ahead and it's going to create basically a deployment through the API gateway. So as you can see right now, the API gateway that I have is completely empty. But when the deploy finishes, you'll notice that it's no longer empty. So while this is actually deploying, I can tell you that the main file of interest, there we go, so it's creating and updating the stack. The main file of interest is the serverless.yml file, and this is where you have the opportunity to specify different providers, whether you're going to use GCP for your functions or whether you're going to use Azure for your functions, or in this case, AWS. Now, I'm not going to lie to you. In some of these providers, the code, you still have somewhat of a dependency, shall we say, to specific providers, depending on what you're trying to do. Like you can see inside of here, I've got a dependency on Amazon, which is okay because you could potentially have different functions which would represent your different providers. And just like Xamarin, you could share pretty much a lot of the logic, a lot of your models, things of that nature. It's just the actual, shall we say, proxies and things of that nature that you may have to write the specific provider code, but it's really not all that much. Okay, so looks like this deployment finished. As you can see, this is a little bit more aggressive. So we've got 5 different endpoints. We've got our 2 gets, one where it gets the whole list, another one where it gets the actual ID, and then we got our post and our put. And if you take a look right here, these are the names of the functions right here. So we've got members, service, dev, create member. So we got create member, get members, update member, and delete member. And the magic in that, again, is the serverless.yml file. But before I dig into that, let me just kind of run this and show you what this does. So before the deploy finished, we had no gateway. If I refresh this, let's see what we got here. We should have had a gateway. Let me take a look at this. Refresh my Lambda functions. Okay, so we do have our create member, delete member, get members. Let me just go ahead and update this. Okay, that was just like probably a caching. It probably had some kind of caching thing going on right there. When I opened up the gateway tab again, lo and behold, you could see our new API gateway, our deployment, and it's dev members service. So what happens, since this is a REST set of REST endpoints and all that, AWS behind the scenes goes ahead and creates this API gateway deployment. So I didn't create this. There was nothing that I did actually to create this. So this gets created itself, which I think is really handy. So if you click on, let's just take a look at the dev stage right here. If you click on this and open this up, you can see we've got our different methods right here, along with the URL that you can invoke. So let me open up Postman. I actually have it open because I was running some tests from previous deployments here. And I'm just going to go ahead and execute the first get right here to return a list of members. And I got to be honest with you, I am mocking the data. So there's no database actually that it's inside of. And that's actually by design because I didn't want to overload this example with specific databases. So if you wanted to use this, go ahead and use your own backing store. So all I'm really doing here on this get when you return all the members is I'm hard coding like an array. So I've got 3 different members. I got a member ID 1, 2, and 3. So that's what happens when you run this first get. And then what you can do if you want to see like an ID, for example, just give it ID 1 and it should just return the first one. So it's going to execute another method, which is what we've got right here. If I do 2, you can see it's returning ID 2. If I give it one that doesn't exist, for example, you're going to get a 404 not found. So now is a good time to actually go into the code just for that spot so you can see what's going on there. So I ran those 2 gets. So I basically took the endpoint, which is you can get it right here, or you can get it from your API gateway. And if you look here, we've got our get member function and our get members function with an S. So this one right here, the first one, the members, it doesn't take any arguments. It's going to return the list of all 3. So here's where it's using that mocked list of data from our repository. So I have a base class right here in C#, and this get all members is just going to go into the repository, and it's just going to return all your members right here. So it's not the prettiest code in the world, but I thought about injecting a service since it was a .NET Core project, but then again, I didn't want to overload this example with code that may or may not be needed by somebody else who's downloading this. So I just kind of wanted to make this as simple as possible. So you'll want to replace this list with going to the repo or something like that. So that's our get all members, and then there's a specific one that says get a specific member. So that's actually going to go ahead and query this hard-coded list, which is a dictionary, and it's just going to do a lookup on the ID and put it into the member record. So get members, we have a method called handle. As a matter of fact, every one of these methods here, there's a consistency of them. They all have a method called handle. And that is the actual Lambda function itself. So if I take a look at the console, and I apologize about some of the other code I have. So these are our 5 methods right here. We have our get member, delete member, create member. The handle method itself is what's going to be invoked. The handler when it actually, if you look right here, so we've got the get member. Our handler itself is called handle, and it's like that for all of the methods that I created in here. So that's why this is called handle. So as you can see, this is going to return get all members, and it's going to return a single member. And again, it's returning, you're returning the standard REST or the best practices, on a get. It's going to return a 404 not found if you can't find it. Otherwise, it's going to do a 200, and it's going to return you the body of the data right there. So that handles the get, the 2 gets. But let's go ahead and do like the post, for example. So this is going to simulate creating a new member. And again, there's no database, no backend database going on here, unfortunately. So we're just going to have to use your imagination. So I'll go ahead and paste this new URL in. So here's ID of 1, and this already exists in our array. So we should actually get, if I run this again, we should get a 409 conflict, which is because of when we do a post, it calls this create member function, and it's just basically, hey, if you already have this, goes ahead and returns a 409. Also, I wanted to, it's returning a 400 if your request is not complete. But let's put in, I know 1 through 3 exist, but let's just put in like 13, for example, because we know that ID doesn't exist. And if you can see, it's returning a 201 created. Now, I've got to be honest with you. I'm not even adding that new member to the array. So if you run this over and over and over again, it's just going to keep returning you a 201. In your app itself, once you insert that record into the database, from there it'll fall through the code where it exists. But I'm not adding it to the array or anything of that nature. So it's really doing nothing here. So same applies to the put, which is like the update. So let's just go ahead and give that a test as well. So I happen to have a put command right here in Postman, and I'm overriding the URL. And this is simulating an update. So if I say like 15, that doesn't exist, for example. So what you're going to get is a 404. If I try to update member ID 2, we know that that does exist. And if you do a send, then we get a 200 OK with the actual data. So if I change this to my title 2, it's going to return that down here. So that ends up calling the update right here to do. So that simulates the update. And then the delete, same thing. So for the delete, let's go ahead and paste in the URL for the delete command. If I click on that, okay, so that's members. And we had, like in this example, we know 12 doesn't exist. So if we try to do that, we should get a 404 not found, which is what we do get. If we try to delete number 1, it'll just indicate that, hey, it went ahead and deleted and returned a 204, no content. So again, if you take a look at the delete member function, I'm not really deleting anything per se. I'm just simulating based on whether it's in there or not in there. But in the code, if you were to actually write your own code to delete, you would actually probably invoke the call to the model in the repo right here, actually to physically delete the record. So that's pretty much a demo of what the API is doing. So again, it's creating your Lambda functions, all 5 of them, and it's using the API gateway right here, which I think is really kind of nice. So the serverless framework, again, it's going to create this pipeline for you so you can actually take a look and see right out of the box what it's doing. And then, of course, you can see it starts with the request and filters the request if it needs to, and then it calls the Lambda and then filters a response if it needs to, or manipulates a response and sends it right back. You're free to go ahead and augment these different stages inside of here to your liking. So there's docs and things that out there that show you how to do that. But again, the main file right here is the serverless.yml, and there's a method to the madness right here. So basically, we're calling this the members service, and because of that, what you end up right here is in the API gateway, it's like dev, which is our stage, and here's our members service. And so that name, the members service, is because of what I called it right up here. And the provider, you can use Azure, you can use GCP. Here in this case, we're using AWS. You specify your deployment package. And by the way, the documentation out there, I don't claim to be an expert at it, as I'm checking into it myself, has a myriad of different properties and stuff that you can fill in here to suit your needs. So, definitely refer to the documentation there if this little starter doesn't get you far enough. And then, of course, you declare your functions. And so this is where we create our create member, get members, update member, and delete member. And your handler is where you wire up the actual function to your Lambda. And if you notice, I call them handle. And again, that has to match the name of this handle method that I have everywhere here. So that's why we call it there. So this basically, for the handler, you got to give it your assembly and your namespace and your class and method declaration right up here. So it kind of has the C++ syntax, if you will, for for getting your classes and your methods right here. The other thing too, what makes this, so the thing that, when we deployed this, the thing that told AWS to create an API gateway was because in the YML file, we have an event section, and when we specified HTTP and all that, the serverless framework said, oh, this is a REST endpoint here. The path right here, as you can see, we've got our path, which is members, and then we've got kind of like a syntax for a parameter, much in the way that you would do it for like C# controllers and such. So this path for each of these has to match, which you've got right up here for the in the API gateway. So if I went back to resources, under Git, let's see what we've got here. So we've got our Git, and I'm trying to, oh, it's right here. Duh, stupid me, it's right in front of me. So that's basically the /members. That's because we've got our path right there. And then our different methods inside of here. So we've got our Git, post, and we've got our put, and we've got our delete. So there's a heck of a lot more you can do with the serverless YAML file. But I kind of wanted to just mention that, that's kind of like the heart and soul of it. So for your different providers, Azure and GCP, you'll want to have a different YAML file or different provider section inside of there where you can specify what's going on. And again, here's our build command. This member repository, it's nothing more than like a mock for the most part. And then our member data, which is just a real simple model of the members. And I did that on purpose so that not to bog down this example or bloat it with other unnecessary things in the code, although those are nice things too. And then I've got the space member function that each of these lambdas will inherit from, that have the convenience methods, the get member and the get all members. And I'm trying to see if there's anything else that I can mention. Oh, I was going to demo removing this. So if we take a look, because I'm going to undeploy it now. So as you can see, we've got, if I go back to our Lambda methods, let's see here, and show you our functions. So you can see we got our 5 members right here. And you can see we've got our API gateway. I am going to show you the CloudFormation stack. So there's our members service right there. If I select it. So as you can see, if you're interested to see what the serverless framework does, when you go ahead and deploy it, you can see all the different resources that it created, API gateway, including some of the permissions. You can see the events that it created. So it's kind of fun to take a look and see the different methods and different resources that you're allowed to create. Unfortunately, the template itself, is not all that well formatted, as you can see. Let's see, we don't have any parameters, no tags, except for a stage of dev, which we can change as well. And let's see here, we've got our description, which you can update in the YAML file. I'm going to go ahead and undeploy this. So I'll say SLS remove. And give it a second to remove. So it's actually going to do the same thing as a CloudFormation delete stack. So I'm going to pause that and wait for that to finish. Okay, that finished. And if we refresh, let me bring this up again. and refresh the cloud, as you can see, the stack is gone. Oh, the other thing too, the Lambda functions are gone. I should have shown the CloudWatch logs. Unfortunately, I deleted this, but I can also redeploy it again. But if we refresh these functions, these should disappear, these top 5. And as you can see, they're gone too. And then the API gateway, if I go ahead and refresh that, that's gone as well. One other thing, if you take a look at our logs, go under CloudWatch and under log groups. Okay, so what I wanted to mention, while the Lambdas were running, we had different log groups inside of there that were created by those functions. Once we undeployed, those went away as well. But keep in mind, so, this deploys your Lambda. Anytime you do your console write lines or whatever, it's going to, put an entry in the CloudWatch logs indicating your Lambda function executions and things of that nature. So each one of these would show up as a part of the request itself. So I think that pretty much does it. I apologize that this kind of lasted longer than I wanted it to, but I have a tendency to do that, to ramble. So again, I apologize. I'll upload this code and put a link to the repo in the video. So thanks again for watching. The serverless API, or the serverless framework, I should say, is really worth checking into. It's pretty cool, actually. So you have a good one, and thanks again for watching. Bye-bye.